So we'll look first at the example on page 18. It is a very simple example. It's about how we bring the complex number to the power 8. And you see I said similar because, in fact, in that example, in notes, I think the power here is 10. Normally, when you go after the power of the complex number, it's just the best way to go after it with the exponential form or trigonometric form. So first, what I will do, I'll bring this number, 1 take I root 3, to the exponential form, right? So here's how I do this. Here's my number, 1 take I root 3. The length of that number is 2. It's like a 1 square plus root 3 squared. It's 4, and under the square root is 2. You factor it out, and that's your factorization. And then when you look at the bracket here, you recognize your standard values of cos and sine. So your exponential form becomes like this, or trigonometric form, cos negative pi and 3 plus I sine negative pi and 3. And well, you can bring it to the exponential form if you want, like this. Now you take this number and you take this number to power 8. So your number W, here it is. You bring it to the power 8. So this is my exponential form. You bring it to the power 8. Now when you look at this quotient 8 pi and 3, you can simplify it a little bit. So the quotient negative pi and 3, you can represent this quickly like so. Negative 2 pi, take negative 2 pi 3. And you know that if you're looking at the complex exponential like this, and your degree is multiple of 2 pi, the result is in fact 1. So this negative 2 pi can be dropped from this fraction. And if you drop it, you will have 2 to the power. So when you bring it to the power 8, is your modulus to the power 8, and that's your exponential, in which we dropped negative 2 pi, and you probably right away you spot a typo here. It must be a negative here, of course. We'll do it simply. It is negative 2 pi I on 3. Here's my negative. Or if you bring this down to the trigonometric form, you know that the cos of this value, of this angle, negative pi I on 3, it's this negative 1/2, and the sine is this value. I have this little diagram here. I can just picture these numbers for you. So this blue vector, it was my number. This blue vector, it was the number 1 take I root 3. So the real part of this number was 1, and the imaginary part of this number was negative root 3. The angle here, we identify this angle, we just did this with you. Here it is, negative pi I on 3. So this angle, this angle, it is, sorry, pi 3, no I. Yes, that's the angle. Now when you raise this number to the power, that's the result we come up with. Here it is. That's the result. The length to the power 8. Well, in fact, if you look at this diagram, this scale not really matches because 2 to the power 8 is by 128 times longer than 2, and this red vector is not by no ways 128 times longer than this blue vector. But anyway, this big angle, that's the one, it's negative 120 degrees, is this angle. So this big spread is angle 2 pi on 3, or in fact negative 2 pi on 3. And you can also identify the real and imaginary part here and here. In fact, I think I did it here somewhere. Here we go. If I continue this line a little bit longer, if I open the brackets, that's the result of that expansion.